All right, so today what we're going to do is we're going to look at determining float times. Now, if you think about it, float times, really we're talking about the flexibility in time, right? So float time means it's talking about how much leeway do we have in the times it takes to complete the tasks. Okay? So we're going to be talking about float times. And it's a simple calculation. All we're going to be doing is doing a little subtraction. And we're going to make a new chart, but you'll see that in a moment too. It's no big deal. So it's a really simple calculation, but you need to be focused. Now, again, the critical path is a special case, so you'll love that. As long as you have the critical path in, all you have to do is put in a bunch of zeros. So, with the critical path, you don't have any time for the thing has to be on time and it has to be finished on time, right? Because otherwise you extend the project so everything's late. But for the other projects that we looked at, the other tasks, there's some leeway in when you get them done. And so that's what we're looking at when we're talking about float time. How much time could I put this off? Or how much time could it run over without affecting any other part of the project? Okay? So that's what float time is. So we're gonna watch the video and then we're gonna take some notes and then you're gonna determine the float times for that building a house project that y'all been working on. Okay. So it's important that you know the definition of total float time and that you can talk about it in context. When you're answering a question, you need to know that if the total float time is exceeded, then it affects the total length of the entire project. So total means the entire project. Okay? All right, let's continue.
This total float time, then you will affect the length of time the project takes by exceeding it, which means that the minimum completion time for the project will be increased, which is not a good thing because time is money. Free float is the maximum amount of time a task's completion can be delayed by without affecting the start time of any other tasks in the project.
Okay, so let's look at the difference between that one. So free float. If you see free, that means probably it's not going to hurt anything, right? Okay, so that's the maximum of time that you can complete a task without, or delay a task without affecting any other tasks. So remember, some of those had those long arrows when we drew when we were drawing our Gantt chart. That means that task could be completed over a long period of time. So it could be delayed without affecting anything else. And that's called free float. And we're going to learn how to compute that in just a moment as well. One way to think of these is total float affects the entire project, and that's bad, right? Free float just talks about a particular task, and that's generally okay unless it gets you really start messing with it. But you're talking about just the time because if it starts affecting the other one, then it becomes part of the total float. It becomes bad, okay? All right, let's go back to the video.
Means that if you exceed this free float time, then you will begin to delay other tasks in the project without necessarily extending the project's minimum completion time. Next, we have to know how to calculate these. So, flipping back to our network diagram, first you're going to want to have a table with 3 columns, and then the second and third column you'll have the total float and the free float, and then you'll have as many rows as you need to cover all the tasks in the project.
Okay, so you see, because here these are the tasks, and we have A through K because that's the tasks we have in our particular project. We have total float time and free float time. So just make a table with these values. Again, remember that this is going to be open notes, so make sure you are clearly writing out what it is that you need. You're not going to be able to watch the videos during the test, but you will have some notes available to you. So make sure you have each piece.
We'll start off with task A, finding the total float. To find this, all you have to do is subtract the early finish time from the late finish time of each task. So task A, its total float is 4 minus 4, which is 0. For free float, it's a little bit trickier, but all you have to
Okay. So let's just write down the math for that. So to find total float, okay, it's simply the early finish time subtracted from the late finish time. So I wrote it a little backwards, right? So it's always these last two boxes, and you're subtracting the bottom one from the top one. So if you look at this one, for example, it would be 10 minus 3, right? So just the last boxes, whatever they are. And what do you notice about the last boxes all along the critical path? They're the same number always, including the front boxes the same. So you're going to see that every time you do float, no matter what kind of float it is, anything in the critical path, you're going to get zeros. So C's in the critical path, so you're going to get zeros. E's in the critical path, so you're going to get zeros. So you can go ahead and fill in all the ones that are in the critical path right away. But again, that reinforces the idea that the critical path is the most important thing to get right. If you get it wrong, then everything else you do after that is going to be wrong. Okay? Mm-hmm. All right. So just the latest finish time minus the earliest finish time. Pretty easy. But make sure you make a note of it because you need to know that that's the one for total float time.
To do is look at the arrows that task A comes out of and goes into. So for example, task A goes to task B and C. These are the two tasks that depend on task A. Next, if you look at the early start time of these two tasks, both of them are 4. Next, you take the lowest early start time and then you subtract the early finish time of task A from that lowest value. For these two, it doesn't matter because they both have the same early start time. But if those...
Okay, so let's do that. That's free float time we're talking about now. So for free float, first, you're going to follow the arrows. Okay? If more than one, use the smallest early start time. Because the smallest one has to be started first, right? So that means you can't affect that one without it having a knock-on effect. So, all right, then all you're going to do is subtract early start from that latest finish. So latest finish minus early start. Okay? Now again, we're talking about for the next project along the arrows. So from here, so this number. Okay? He's going to do some examples so you can see that. Ready?
Different, you would take the lower. So this one, they're both 4, so you just take 4 and subtract 4, which is again 0. Now all you have to do is just do this for the rest of the tasks in the project. Next we'll go to task B, and to find the total float, we subtract the early finish time from the late finish time. So 10 minus 3 is 7. Next, find free float for task B, we find the other tasks which depend on task B. So this one, all we have is task A. Next, we subtract the early finish time of task B from the early start time of task A, which is 7 minus 3, which is 4.
Oh, sorry, I wrote the wrong one. So it's early finish minus early finish. Sorry about that, guys. I wrote late finish, but it's early finish. Okay? So, for example, in this one, we would be taking this number minus that number. Okay? So they're on the same level. Sorry about that. I misspoke on the last one. Okay? So change that to early finish minus early finish. Or early start, I'm sorry. Early start. I can't decide which one's finish and start. Remember the boxes. Let's just do those again. This is early start. This is early finish. This is the task. This is the duration, right? This is early finish. This is late finish, no, early finish and late finish. So that's late start. Oy vey. Let me try that again. I need to stay home some days, I swear. Okay, so early start, early finish, late start, late finish. Y'all know it better than I do. Good. Because I don't have to take the test, y'all do, so that's a good thing that y'all know it better than I do, right? Okay, so you're going to take early start, right? So right here, minus early finish from the one begin. Make sense? So here, this one is early start minus that one. Yes? Okay, he's going to do about 17,000 others. You know he does every single one of them every single time. So you'll see it all. Okay? All right, early start minus early finish. What's really annoying is that these are recorded, so everybody gets to see when I make a mistake forever. Here we go.
C, and to find the finish float, we subtract the early finish time from the late finish time, which again is 7 minus 7, which is 0. And to find the free float, we look at the two tasks which depend on task C, and we take the lowest of the two tasks' early start times, as they both have the same, it's just 7, and then we subtract the early finish time of task C, which is 7 from it. 7 minus 7 is 0.
And that's going to be 0 because it's in the critical path, so you know it's going to be 0.
Task A and task C both have total floats and free floats of 0. This is actually because they're part of the critical path, and what it means is that each task in the critical path cannot be delayed at all without either affecting other tasks in the critical path or extending the project's minimum completion time. So for each task in the critical path, they'll all have a total float and free float of 0. Then next we'll go into task D, and to find the total float, we subtract the early finish time from the late finish time, which is 21 minus 6, which is 15. And next, to find the free float, we subtract task D's early finish time from task K's early start time, which is 21 minus 6, which is also 15. Task E is a task in the critical project, so just like...
Right, see what he did? First, these two subtracted, because you're only talking about the total float, so that's the total amount of time that can be just delayed without affecting the other project. And then it's this one minus that one to get the free float. See where the numbers are coming from? Okay.
Like tasks A and C, we can just give it a 0, the total float is 0 for free float. And the same for task E. Task D has a total float of 19 minus 13, the late finish minus the early finish time, which is 6. And then to find the free float time, we subtract task D's early finish time, which is 13, from task I's early start time, which is 16. 16 minus 13 is 3. Next up, we have task A, which has a total float time of 19 minus 16, which is 3. Then it has a free float time of task I's early start time, 16. Take away task H's early finish time, which is also 16. 16 minus 16 is 0. Next up, we have task I, and to find its total float time, we subtract 18 from 21, which is 3. And then to find the free float time, we subtract task A's early start time from task I's early finish time. 21 minus 18 is 3. Next up, we have task J, which is in the critical path, so it has a total float and free float of 0. And then we have task K, which also has a total and free float of 0, as it is in the critical path. And there are your float times.
Okay, so what's going to happen is you're just going to need to practice these so that you know which ones to do once you get in the flow of it, and make sure you write down the notes properly. Oh, that would be nice. And once you get the flow of it, it's no big deal. Okay? And then you're going to be, and for the excellence part of these questions, you're going to be asked some questions. For example, you might be asked, what effect would delaying task J have for 5 hours? And for that, you need to look at your float time. And if the 5 hours is within the float time, then it has no effect on anything else, right? But if it isn't, then that's going to delay either the project or delay the next task. And you need to determine that by looking at the total float time and the free float time, right? Because they talk about two different types of delays. Okay? Alrighty, so you're going to go back and practice some of those.